Looking at Module 10, Lesson 2, and you can find that on page 245 of your math workbook. So 245. All right, spark your learning. Today we're looking at how to identify factors in a problem. Miss Aisha owns a bakery. She wants to put all of these blueberry muffins in a display case with the same number of muffins on each shelf. Which display case should Miss Aisha use? Well, first we need to know how many muffins Miss Aisha has. So let's count them. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. She has 16 muffins. So now we need to decide, and we're going to put them on 3 shelves or 4 shelves. So we're going to use visual models. So today for our visual models, we're going to continue with what we did yesterday. We're going to use arrays. So in the first one, we know we have 3 shelves, so we're going to have 3 rows. So 1, 2, 3. And then we have to decide how many muffins are we going to put on each row. So what I'm going to do is I'm going to distribute out my muffins to make them on equal rows. And remember, if we're putting on, we got to have the same number of muffins on each shelf, so we're making equal rows. So I'm going to say I've got 1, 2, so we had 16. So I'm going to go 1, 2, 3, and mark them out. So 1, 2, 3, okay. So we've got, puts us 1, 2, 3, 4, 5, 6, 7, 8, 9. So we've used 9. Okay, then we're going to do 3 more. So 1, 2, 3. Let's do, we can do 3 more. 1, 2, 3. And then we have 1 left over. So we've got 1 left over. So that tells me right there that I don't have an equal number of muffins on each shelf. So I'm going to try it with 4 shelves. So we've got 4, that represents 4 rows. I'll say 1, 2, 3, 4. Okay, then we're going to distribute out our muffins. So we're going to mark them out again. So we're going to use, so we're going to say 1, 2, 3, 4. So that would be 1, 2, 3, 4. Okay, we're going to make another group. 1, 2, 3, 4. We can do it again. Say 1, 2, 3, 4. And then we can do it one more time. 1, 2, 3, 4. And we've used all of our muffins. So if we complete our array, we see here that we have 4 rows with 4 muffins each. Here we had 3 rows. 2 of our rows had 5 muffins, but our first row has 6 muffins. So we can't say that we have equal rows here with our 3 shelves. So our answer is going to be that Miss Aisha should use the case with 4 shelves because we can put an equal number of muffins in each shelf. So let's move on to page 246 and let's continue practicing how to identify factors. Okay, Miss Aisha makes a new kind of granola bar for her customers to try. She wants to display 40 bars in equal rows on a tray. Can Miss Aisha place all the bars in 5 equal rows? Well, let's think about using a visual model to represent this problem. So we're going to use an array again, and let's think about it. So she wants to put all her 40 bars in 5 equal rows. So I'm going to come over here and I'm going to start with my array by making 5 rows. So I'm going to say 1, 2, 3, 4, 5. Okay, so that's going to represent my 5 rows. Now I need to know how many bars I can put in each row. So we could simply think about a multiple of 5 that would equal 40. So I would say in my head 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15, 5 times 4 is 20, and I'm continuing with that. 5 times 5 is 25, 5 times 6 is 30, 5 times 7 is 35, 5 times 8 is 40. So I know that I can divide 40 by 5. So I'm going to put 8 bars in each row. So we're going to count as we draw. 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 bars in each row. What shape does your visual model show? So looking at our array, we see that we have a rectangle. What does this shape tell you about whether or not all the granola bars can be placed in equal row? Well, to what we know about rectangles, we know that rectangles have equal rows. So we can start with that. So knowing that rectangles have equal rows, that tells us that all the granola bars can be put in equal rows. All right, let's look at C. Can Aisha put all the granola bars in 5 rows? How does your visual model show this? So let's answer the first question. Can she put them in 5 rows? The answer is yes, she can. How does your visual model show this? So there are 40 bars. So there's 40 bars. And our visual model, so we can say my model shows 40 squares, or 40 grid squares, in 5 equal rows. Equals the key word there. And then let's look at D. Is 5 a factor of 40? How do you know? So let's answer the first question. The first question, the answer is yes, but how do you know that it's a factor? Well, I know that by putting 40 into 5 equal rows, that gives me an equal number. So I could simply say, I can put 40 into 5 equal rows, which shows me that the number of rows times the number in each row equals factor times factor. Equals my factor times my factor. All right, let's continue on. Let's practice that again. And this time we're going to go to page 247. So 247. Now remember with my videos, because of the way I have to do my board, you can pause the video and finish working on your answers in your book. So if you need to do that, and you can always rewind the video and go back and fix those answers. So you can go back and forth on the video. All right, number 2. Miss Aisha has 35 loaves of French bread. She wants to put the same number of loaves in 3 baskets. She can put all the loaves in the, can she put all the loaves in the basket with none left over? Let's look at A. Why can we use division to solve this problem? So instead of using an array this time, we're going to use division, which is something that we've done in previous models. So let's look at our possible answers. Why would division work to solve this problem? Well, think about it. Back when we were discussing division,
we talked about how it's just like creating equal groups.
So with division, is making equal groups. That's what you're doing.
So I need to know if 35 loaves will go into 3 separate groups or 3 equal groups. So let's look at B. Complete the division and show your work. Okay, let's start with the number in the tens place. We have a 3. So 3 divided by 3 equals 1. So we know that 1 times 3 is 3. Then we subtract. 3 subtract 3 is going to give us 0. We're going to bring down our 5. Now let's think about this. What number multiplied by 3 is going to get me close to 5? So let's think about our multiples of 3. We got 3 times 1 is 3. 3 times 2 is 6. We know that 6 is too high. We can't go past 5, so we're going to use the 1 again. 1 times 3 is 3, and we're going to subtract. 5 subtract 3 is 2, so we have a remainder of 2. So now let's see if we can answer our question. Look at C. Can all the loaves be put in 3 baskets with the same number in each basket? The answer there is no. How do we know this? We can say I divided 35 by 3 and got 11 with a remainder of 2. So that tells me that I have 2 loaves of bread that aren't going to go into any basket. So there's 2 extra loaves. Look at D. Is 3 a factor of 35? How do you know? So let's take a second before we answer this question and look at the word factor again. Go over to your vocabulary and you see that a factor of a number divides that number evenly. The quotient, which remember is the answer, is a whole number and the remainder is 0. So let me read that one more time. A factor of a number divides that number evenly. So evenly there, that's an important word to remember. The quotient is a whole number with 0 left over. So is 3 a factor of 35? Well, we had something left over when we divided it, so we can say that the answer to that question is no. But how do we know that? Well, a factor is a number that divides a number evenly. So if it's dividing it evenly, there will be nothing left over. So when I divided 35 by 3, I had a remainder. So that tells me because I have a remainder, 3 does not divide 35 evenly. I can't break it into equal groups. Okay, let's move on to page 248. Let's continue practicing this together. So on this next page in Step It Out, we're going to look at divisibility rules. So we're going to see that chart. You might want to circle this chart or put a star by it because that's important, something that you need to remember. Something else is we need to look at our vocabulary. It says a number is divisible by a second number if the quotient is a whole number and the remainder is 0. So if a number is divisible by blank, then that number is a factor of that number. So that's a lot of information there. So let's just practice this. Let's look at our question. Is 6 a factor of 84? Use divisibility rules to answer and explain. So we've got some different rules here. The first one is if a number is divisible by 2, then that number is even. If it's divisible by 3, the sum of the digits is divisible by 3. So look at the word there, sum, so you're adding. Number 4, If the number is divisible by 4, the last two digits form a number that is divisible by 4. For 5, the last digit is either a 0 or a 5, and that tells me I can divide it by 5. A number is divisible by 6 when the number is divisible by either 2 or 3, or and 3. And then a number is divisible by 9. The sum of the digits is divisible by 9. So let's just look at these questions and let's use that divisibility rules chart, to see if we can answer these questions. So is 84 divisible by 2? So let's look at our rule for 2. The number has to be even. So is 84 an even number? Well, go back and look at your ones. Is 4 an even number? Gotta know your different numbers. 4 is even, so we can say that yes, 84 is divisible by 2. 84 is even. All right, let's look at B. Is 84 divisible by 3? So now let's go to our divisibility rule for 3. If the sum of the digits is divisible by 3. So we have to take 8 and 4. So we say 8 plus 4, because we're talking about sum, so we're adding, is 12. And we know that 12 divided by 3 equals 4. So the answer here would be yes, it is divisible by 3. All right, let's look at C. Is 84 divisible by 6? Let's look at the rule for 6. The number is divisible by 2 and 3. Okay, so let's look at it. Well, we said earlier in A and B that we could divide 84 by 2 and we could divide it by 3. So if we can divide 84 by 2 and 3, then we can divide 84 by 6. So the answer here would be yes. So 84 can be divided by 2 and 3. All right, let's look at D. Is 6 a factor of 84? Is 6 a factor of 84? Now, thinking about that, we have to go back to our vocabulary. So if a number is divisible by 6, so if 84 is divisible by 6, then 6 is a factor of that number. So using that definition, we can say that yes, 6 is a factor of 84 because 84 can be divided by 6. All right, now I want you to pause the video and I want you to complete check understanding on your own. Be sure when you're doing the check understanding that you go back and you use the divisibility rules chart to help you answer this question. Okay, Miss Ayesha wants to put 51 bagels in bins with the same number in each bin. Should she use 3 or 4 bins? Use factors to justify your answer. So looking back at our divisibility chart, so if we go back up to our divisibility chart and we're looking at our rules of 3s and 4s. So let's think about 51 divided by 3. So we can take the number 5 and we can take the number 1 and we can say, add those together and we get 6. Well, can I divide 6 by 3? And my answer is yes. I can divide 6. 6 divided by 3 is going to equal 2. So she can use 3 bins, but let's check and look and see if she can also use 4 bins. So we look at our rule of 4. The last two digits form a number that is divisible by 4. Well, we said that 5 and 1 equals 6 when we add those together. And with those two together, 6 divided by 4 is not going to give me a whole number quotient without a remainder. So what that tells us is that 3 is a factor of 51, but 4 is not. Okay, and just remember, it's got to be even rows. So if we think about it, if she uses 3 bins, all the bagels will fit evenly, or you could have used the word equally, and there's none left over. So another way that you could have written that was you could have said that 5 plus 1 is 6, and 6 will divide by 3 evenly, and there's no remainder. So that shows that 3 is a factor of 51. All right, make sure that you have all of your answers written down for this lesson, because you will be able to use it to help you review for your tests.